Now let's learn about drift velocity. Okay, what's meant drift velocity? First, let's take a conductor. It means a piece of wire. I'll take a cylindrical shape with this way. Okay. Now electrons we see inside. Okay, electrons that way, this way. Each electron will go in different random directions. We know. Okay, because of temperature, because of other factors and all, the electrons will be in continuous random motion. There are electrons there, free electrons we learned, but they will be in random motion. They won't be in a particular direction there. They won't go in one direction. They won't travel it. Okay, so we can say if you just take one wire and connect to a bulb, the bulb will not work. Okay, because even though there are electrons there, the electrons are moving in a one direction. Now let us see what will happen if you take a wire and then you connect to a cell. Okay, so let me take a wire here. I'll draw it very big now. So this is a wire here. Okay, let me draw like this way. This should to show the atoms also. Okay, so this is a atom here. All these dots are the atoms here. Okay, now we connect to a cell like this way. So let me take, this is the negative and this is the positive. Okay, so this is a negative and this is a positive. So sorry, positive. So electrons will start coming from the negative end like this way. I'm taking the electronic current. Okay, the direction of electrons will be like this way. So we can say electrons will go this way. Okay, so let's take an electron here. Okay, what will happen to the electron? Will go in straight direction. Okay, so you know this is an ion here. Actually, if you say take a metal lattice, learn chemistry also, there will be ions only. Okay, so it may be positive, so it will be attracted towards the positive. Okay, it won't go straight. It may curve like this way. Then sometimes it may hit the atom also. Next one it may hit. Okay, when it hits, it will change direction. Direction may change. Okay, so again it hit this. So it will keep on be going in a zigzag pattern like this way. Okay, each and every electron, and then so not here, it will go here. Okay, so it will travel in a zigzag way. Okay, so electrons we see, they won't go straight into a wire. They just travel in a zigzag way. Okay, now let's see, will electrons go very fast? Okay, no, the electrons don't go very fast. They go very, very slowly. Okay, let me draw it and explain to you how it is. Okay, shall draw it here. Okay, draw it here. So we say the electrons move slowly. Yeah, right here. Electrons move very slowly. That's called as drift velocity, we say. Okay, so how to show drift velocity? For example, so let me take a small pipe here. Okay, like this way. In this pipe, we can put a lot of beads there. Let's say each one is a bead. This is a bead here. This is second bead, third bead, fourth bead, like this way. Okay, some plants also produce seeds like this way in a perfect spherical shape. Okay. Now what we do is we take one more bead and then we push it inside. Okay, then what will happen? This will push the next one. Okay, this will push next one like this way, and finally this will pop out. Okay, so in this way, same way only electrons also travel in a wire. Okay, one electron will push the next electron. Okay, and what happens is actually the electron movement is very slow only. Okay, each thing you see, this distance will be very, very small distance here. Okay, and it will travel very small velocity only, but the way it goes now travels, each one pushes it, and then finally the electrons will travel together in the speed of light. Okay, close to speed of light, you can say. So it may look confusing first, but it's very simple only. Okay, let's see. The electron will push, so this, let's take this as an electron. This electron will push the next one. This will push the next one. In this way only it will travel, and each electron goes very, very slowly. This velocity we call it as a drift velocity. We write as Vd. Okay, Vd stands for drift velocity. Let's see how to find expression for drift velocity. Okay, so we know from Newton's second law, force F is equal to m into a. Okay, this we know. Let's take charges here. We have the formula F is equal to QE. Okay, but what charge we are taking? We are taking electron. So F is equal to electron E into E. Okay, this is the formula here. But if you see electron charge is negative, so write as minus sign. Okay, now you compare both the equations. Okay, so this is 1 and this is equation 2. So combining equations 1 and 2. Combining equations 1 and 2. So we combine these two, what happens? We get MA is equal to minus E into E. Okay, we want to find the acceleration, so bring the M down. So acceleration A is equal to minus E into capital E by M. This stands for the acceleration we get. Okay. Now let us see how to find the drift velocity. We want to find the drift velocity only. Okay. What speed the electron will travel from one atom to next atom. Okay. So one more thing, you must notice that this is an atom. This is another atom. Okay. An electron goes here. It will collide with the next atom. Okay. And then afterwards it will jump here. Then it will go here. So you see there will be collisions there. Okay. So between each collision there will be time here. That time I say tau. Okay. I'll write little larger in size. Tau. Okay. This stands for the mean free time we see. Okay. Mean free time. Okay. This is a concept there. Okay. We'll use it now. So where we use it? Let's see what's the formula for acceleration. Acceleration is equal to velocity by time we know. Okay. So how to find velocity? Cross multiply this way. So acceleration into time, or write A into T is equal to V. Rearrange, V is equal to AT. Okay. I'm going to use this formula here. All this concept we're going to use it here. Okay. Let's see now how to find the velocity. So we need to find drift velocity, is VD. Okay. We know velocity is a vector quantity. Okay. That's equal to acceleration here. Okay, we got the acceleration. Acceleration is a vector. Okay. Then time, instead of time we write as tau. Okay. Tau. T-A-U. Okay, this is how to say it is tau. Right here. T-A-U. That means it's a Greek alphabet. Okay. Now what we must do is this acceleration is it's a vector quantity. I'll write you vectors here. Okay. Electric field is a vector quantity. Okay. Now we can substitute this. Okay. Just substitute the values here. Substitute values. Value of A. What we get here? VD is equal to minus of E into capital E by M into tau. Okay. Vectors. Write the vector here. Vector on top of E. Okay. I'll rub this part and then I'll continue the side. Rub all this. Okay, so now we got this concept here. I'll write the same equation on top. VD vector is equal to minus E into capital E vector by M into tau. Okay, what's tau means? The mean free time. Okay, time between two collisions. Now what we do is we'll just slightly rearrange this equation. Let me take chalk here. Slightly rearrange. So VD is equal to minus E into this tau I'll write here. Tau by M into electric field E. Okay. Now this quantity E into tau by M. E means charge of one electron. Okay. Tau is the mean free time. M stands for the mass, okay, of the electron. So you take this quantity. This quantity we say it as mobility. Okay. We have a symbol here. I'll write and show you. So VD is equal to minus mu into E. Okay. Here mu means mobility we say. I'll write this side. So mu means mobility. Okay. So now let's see how to find mobility. Okay. So we want to find the value of mu. Okay. Just cross multiply or bring this E down. Okay. So what we have is VD by E is equal to minus of mu we'll get. Okay. So vector. Okay. So how to find mu from this? Mu is equal to minus of VD vector by electric field E. Okay. I'll write vector. Electric field E vector. Now we must take the minus sign outside. Okay. Or we don't want the minus sign. So what we do? We take the modulus here. Okay, excuse me. So we take the modulus here. So we get here mu as mobility is equal to modulus of drift velocity VD by modulus of the electric field. Okay, so we take modulus, the minus sign will go away. Okay, so let's see now. Last thing we'll see what is the S unit of mobility. Okay, S unit. So S unit of velocity. Okay, drift velocity, any velocity, meter per second. Okay, I'll just derive and show you. Meter per second divided by what's the SI unit of electric field? That is volts per meter. Okay, so what happens is meter will go up. Okay, so as it goes up, we get meter into meter will come as meter square. Okay, so and volt second will come up. So we get here SI unit of this is meter square by volt second. Okay, so this is how we get the SI unit also. Okay, so it's just simple concept only. Okay, so drift velocity means what? It is the velocity with which an electron travels between collisions. Okay, so between one collision next collision, the electron will travel slowly. Okay, it's not very fast, it's very slowly. Okay, but why, what happens is the electrons push each other now. Okay, it's like a chain reaction, and then that will that chain reaction happens near at the speed of light. Okay, that's why we get the light glowing as soon as switch on a button. Okay, so drift velocity means the velocity with which an electron travels from one place to next place or between two collisions. Okay, mean free time we learned, that's tau. Okay, time between two collisions, and now we got another concept called as mobility. Okay, so this value you just note down. Okay, and then they may ask in 1 mark questions and all. Okay, define mobility. Okay, or what is drift velocity? It's a very important question.